Let's continue talking about practical feed formulation and feed formulation programs. The least cost formulation approach will combine available ingredients in certain proportions in the diet that we're trying to formulate in a weight or in a ratio that minimizes the cost of the final diet that we want to have. How computers do this? Computers do this by using different algorithms. Algorithm, it's a fancy word to say it's a set of rules or a set of calculations that are applied to solve a mathematical problem. So, in other words, the computer will do the hard math for us, as we saw in the case of the Pierce square with multiple ingredients. We can run that, and we can do it by hand with as many ingredients and nutrients as we want to. It's just going to take a lot of time, and the computers do that job very fast. Because we're using computers and then they're very good at performing calculations, there's one thing that we can say with certainty. The mathematical solution to any feed formulation that comes out of our computer is mathematically correct. Now, that doesn't mean that we can feed that formula to a pig or that formula is going to be appropriate to a pig. For example, if you provide only two ingredients, soybean meal and salt, to a feed formulation program, and then you ask for the feed to contain 20% crude protein, yes, it's going to probably be, I don't know, something like 40% soybean meal and about 60% salt. You combine those two ingredients in that proportion and you probably end up with something around 20 or so, whatever percent of crude protein. So mathematically, that formulation is correct. Now, you will never feed a diet to a pig that contains 60 or 65% salt. It's simply not edible, but the computer is not able to perform those logical tasks. Those tasks are up to us, the nutritionist. The other thing that the computer will do is that will find the combination of the ingredients that will give me the mathematical solution for the nutrients that I requested to, taking into account the constraints that I put for any of the ingredients, and it will try to combine those different ingredients in a manner that will give me the lowest possible feed cost. Least cost formulation has many advantages. One is it's easy to add and remove ingredients to the formulation, contrary to hand. I mean, there's a lot of calculations that need to be done. The computer does that very fast. Those calculations are performed very fast, and they're very, very reliable. Because those calculations are quick, we can evaluate multiple ingredients at the same time, and we can put different ingredients to compete with each other. For example, let's say I may have at my disposal wheat as well as corn, and I want to know with the nutrient profile of corn and the nutrient profile of wheat at a specific cost for corn and wheat, I can put both of them at free choice to the feed formulation program, and the program will tell us what it's the most economical proportion in which we can combine those two ingredients. So we can easily recalculate formulations, whether we have a change in the nutrient content or nutrient contents, if we change more than one nutrient, or if we add or increase ingredients or types of ingredients that we add to the diet, if we change any constraints, minimums and maximums inclusions of ingredients, or even if we change the cost. Because we're talking about here a least cost formulation program, we need to keep in mind that every time that we'll change the cost of any particular ingredient, there is a likelihood that the formulation is going to change. As we mentioned before, and I'll mention it again, the feed formulation programs, they do the math for us, and they do it very fast, they do it very accurate, and their solutions are pretty much always correct from the mathematical point of view. The results can be fast and can be very reproducible. You can use different ingredient formulation programs. If you have the same nutrient profile and you have the same cost, and then you have the same constraints, very likely those 2 or 3 or 4 different feed formulation programs are going to give you the same answer, because that's just the way the math works out. It's easy also to force in expensive ingredients that otherwise the program will say, I'm going to kick them out because they're too expensive. For example, if we want to include a 3.5% spray-dried plasma protein in a phase 1 pig diet, if we don't force that saying, I want this, most likely the program is going to kick it out because you say, it's too expensive. I have other ingredients that can provide protein that are cheaper. So again, the computer is not thinking about, let's say, the benefits of a product like a spray dry for a wind pig diet. It's simply trying to run the math in terms of, I need to meet these nutrient needs and I have these ingredients available at this particular cost. The speed of computation has nothing to do with the integrity and the accuracy of the calculations. We can trust the computers that what they're doing very fast is very reliable. And then the other advantage of the least cost formulation is that it will increase the profitability of the feed mill or the profitability for the swine producer, because we're trying to formulate for a feed that has the lowest possible cost. Like anything in this life, it has its advantages and disadvantages. So least cost formulation has also some limitations. And the first one that comes to mind are the ingredient constraints. What do you set as minimums and maximums? For example, you don't want to formulate a diet that will have 5% salt included in there. That would be something that we refer to as a maximum. Like in the previous slide, we talk about including spray dry plasma because it's an expensive ingredient. We probably want to force that and say, like, use plasma at a minimum of 2% inclusion, and the program will put 2% inclusion regardless of what the cost is. So we're forcing those things in, and then forcing those ingredients need to be done by hand. The nutrient needs that we put in, we calculate those, and those need to be input into the least cost formulation program by hand. The nutrient profile or the nutrient matrix of the ingredients also need to be input by hand. In some cases, we can have programs that are connected to NIR machines and they can do that, but not all the ingredients are actually done on a real-time basis or come from another, let's say, computer. There's a lot of data that is input by hand. The cost of ingredients, it's also input by hand. And then you can start to see here the pattern that says input by hand, input by hand, input by hand, input by hand. Why is this a limitation? This is a limitation because we can have errors, type errors, as we input any of these numbers into the feed formulation program. The formulation depends on ingredient cost and nutrient profile. So if you change the nutrient cost of any or all of the ingredients, then the formulation will likely change. Same thing, errors in the database that we can put in, the computer is not going to know about it. I can easily go into any feed formulation program and assign a crude protein value of 23% to corn, and the computer is going to accept it. It doesn't have that logical knowledge that says, like, well, corn at 23%, it's simply not possible. We're still not there yet with the feed formulation programs that are currently available, and therefore we need to exercise judgment, and we need to depend a lot on the knowledge of the nutritionist. Things that the computer will not do. It will not judge digestibility, palatability, or adequacy of ingredients. Again, I can talk about here making a diet, phase 1 diet for newly weaned pigs with a 30% of inclusion of soybean meal. The program will solve it, and mathematically the numbers are going to be spot on. We know that based on our nutrition knowledge, that a 30% soybean meal inclusion for a phase 1 win pig diet will be absolutely disastrous, and that is going to cause an allergic reaction that is too big, and we'll see that more in detail in further talks. But basically, that is something that mathematically will be correct, but we know that nutritionally is probably not the right thing to do. Dangerous or inadequate or even toxic levels of ingredients, if we don't set them up, the computer is not going to know. If we end up formulating a feed and that feed has a 0.5% inclusion of selenium, well, that is an extremely toxic level of selenium. The computer is not going to know. And mathematically, if we have not put a maximum level for selenium, if we let them free floating, or if we make a typo, the computer is going to say, hey, if selenium is not within your constraints, I'm not going to care about it. And then the computer 0.05 or 0.5 or 5% of selenium, it's the same thing. It's simply going to calculate it and give us a mathematically accurate numbers, but those numbers are not necessarily nutritionally adequate. So how does a least cost formulation program looks like? And I'm going to try to explain this in a visual way. This is not the way that it's done, but this is a way to try to illustrate sort of like how the process goes. First, we offer some ingredients, and we also set some nutrient values. And then we ask the program to formulate. The program will do the math and will fill the needs for all the nutrients that we provided. If we don't provide values or needs for nutrients, the computer is simply not going to take them into account into the calculation. Then after it fills all the nutrients, it's going to calculate the cost, and then as we do this over and over again, he's going to calculate one cost, then another cost, then another cost, until it finds, let's say, the lowest cost. Like I said, this is not exactly how they do it, but this is how you can think about it, how I will do it in your head. And it will go into this loop until I find a cost. This is like, hey, I cannot lower anymore. This is the lowest cost I can find. And then it gives you the results. And say, this is the lowest cost that I found out. Then it displays the ingredients in the formulation with the different proportions, and it's going to give you also the nutrient profile, and everything that you ask for most likely is going to be met. If it cannot be met, it's because you're asking numbers that are just not mathematically possible to achieve, and then the program is going to go through an internal selection of criteria, and it's going to give you an answer that is not right, but at least for one or more of the nutrients is going to be right. And it's therefore very important that we revise those numbers both on the ingredient side as well as on the nutrient side. Make any adjustments that we need to, find out everything that did not go right, everything that doesn't look right, we go find it adjusted, and then we offer new ingredients, change the constraint of those ingredients, or change the values of nutrients, or set new constraints for new nutrients, or input new values for new nutrients, and then we ask the program to formulate again. There are two main types of least cost formulation programs, and I'm not talking about here about brand names. I'm talking about here the backbone, how the calculations are performed. One type of, or one family of feed formulation programs will use linear programming. Linear programming, it's basically a set of mathematical rules and algorithms that will be used in order to combine the ingredients that we have offered with the constraints that we have offered, and the cost of each one of those ingredients and nutrients, as we'll see here in a little bit, and basically provide them in an arrangement in a certain fashion in order to fulfill the needs that we're asking for. But it works on what I'm going to call absolute values. The other one is stochastic formulation. Stochastic formulation, what I want you to think about it is, it's linear programming plus statistics. What I mean plus statistics. Remember then, for example, when we are talking about the level of crude protein in corn, well, because we never use one corn, we're using corn over and over and over and over again. So we're always measuring the level of, let's say, crude protein in corn. We could talk about the level of lysine, methionine, calcium. It doesn't matter what nutrient it is. If we go to the tables and the numbers that we find in the tables, those numbers are averages. Because they are averages, like any number that is an average, and we talked about previously about the requirements also being averages, there is a variation that we can express as a number, a variation that is associated with any average or with any mean. When we go to a stochastic formulation, it's like linear programming, but we add statistics. And at that point in time, we basically were asking to formulate a feed with a confidence level that would for sure have a minimum amount of the nutrient that we want to take into account. Therefore, in stochastic formulation, these programs will take into account not only the nutrient composition, as we normally do, but would also require an error term or a variation term, a standard deviation, a standard error, a coefficient of variation, some type of variance, and then they will perform not only the linear programming, but also will do a statistical analysis, and it will give you a result that will tell you that with an X amount of confidence, this diet will contain Y amount of this particular nutrient. So we've been talking about least cost formulation. So let's think about how we talk about cost, and specifically how we talk about nutrient cost. We know what the cost of ingredient is, but let's think about how we calculate nutrient cost. In this very simple example, we're going to calculate the cost per unit of nutrient. And we're going to do it for corn, and we're going to do it for wheat. And we'll continue working for crude protein as an example. So when we say that corn has 8% crude protein, that's basically 8 grams of protein in 100 grams of corn, which is the same thing as 80 grams of crude protein in 1 kilogram of corn, which is the same thing as 80 kilograms of crude protein in 1 metric ton of corn. If we say that the metric ton of corn costs $300, well, the kilogram of protein is the $300 cost of 1 metric ton of corn divided by the 80 kilograms of crude protein in that metric ton, and that gives us a cost of $3.75 per kilogram of crude protein coming from corn. If we do the same thing with wheat, and we say, hey, wheat is 10% crude protein, that, remember, percent means per 100, so 10% crude protein is 10 grams of protein in 100 grams of wheat, and then that is equivalent to say it's 100 kilograms of crude protein in a metric ton of wheat. If a metric ton of wheat costs $400, then the cost, which is 400 divided by the 100 kilos of crude protein that we have, then the unit cost of protein is $4 per kilogram of crude protein coming from wheat. In this case, if we put corn and wheat in the same formulation, we can clearly see in this example that the cost of nutrient, in this case, the cost of protein, it's lower in corn compared to wheat, and most likely the formulation is going to favor to use corn rather than wheat in the formulation from the simple fact that it's cheaper, not on a per metric ton basis, but on a per nutrient basis. And we'll see how can this be changed. Now, the cost of all ingredients and all the nutrients will be considered during the least cost formulation. So there's a lot of math that needs to be done here, and this is where computers are wonderful because they'll do all that math for us. If the crude protein content and or the cost of that ingredient varies, then the proportional, the cost of that nutrient in that particular ingredient will change, and the results could be different, and then the selection of ingredients could be different, and we'll try to illustrate that in the next slide. Now let's see what happens if we vary the cost and the percent of crude protein in the ingredients. And again, we'll stick with corn and wheat just as an example. And again, these are all arbitrary numbers just to illustrate the point. Let's say now that our corn is coming out at 7.5% crude protein and the cost per metric ton is $320. We do the math and then we find out that 1 kilogram of protein from corn has a cost of $4.27. Let's go and look at wheat. Wheat now contains 10.5% crude protein and the cost is $425 per metric ton. When we calculate the cost per kilogram of protein, it comes out to be $4.05. Now, in this particular example, the unit cost of protein it's now cheaper in wheat at $4.05 compared to that of corn at $4.27. Now we can see here that the cost per metric ton it's still cheaper for corn than it is for wheat. But the unit cost of the nutrient, in this case protein, it's cheaper in wheat than in corn. And in this particular case, now the least cost formulation is looking at these numbers and it's saying, it's like, hey, if you're asking me for crude protein, then I'm going to use as much wheat as I can because the protein from wheat is cheaper than the protein coming from corn. And it will do this for the rest of the amino acids, the energy values, and all the other nutrients. And then it will put all this into consideration. And this is the point that I wanted to illustrate as in a simple manner to say that the formulation of a feed on a least cost basis will depend on both the content of the nutrients as well as the cost of the nutrients. And if any of those changes, or if both changes, then likely there are some things that will need to be adjusted in the formulation because now a nutrient coming from an ingredient is now either more expensive or more affordable, and therefore the computer program will adjust it in order to give us the lowest possible cost of that feed. When we're talking about the nutrients that we balance during feed formulation, normally we're talking about, particularly in pigs, we're talking about metabolizable energy, perhaps net energy, or some form of energy, crude protein. The amino acids usually are lysine, threonine, tryptophan, and the total sulfur amino acids. And then we formulate for calcium and phosphorus as well. Now, the nutrients that we normally balance for, in addition to the ones we just saw before, we'll get valine, isoleucine, phytase. And phytase is not a nutrient, but we will input a level of phytase, and we can ask and we can add phytase as a nutrient to be formulated if we wanted to. Within the minerals, we also look at the levels of sodium, chloride, copper, and zinc are very common to look at because we can use them levels of pharmacological levels of zinc oxide and different sources of copper to prevent diarrhea in the case of zinc oxide, and also to stimulate growth in the cases of the sources from copper. Feed additives, medications, other ingredients, lactose. There are a variety of things that we can consider a nutrient from the point of view of formulation that are not technically necessarily a nutrient. We can talk about medications. For example, let's talk about an antibiotic. We can put an antibiotic and set it up as a nutrient. Is an antibiotic a nutrient? No, it is not. But these are the beauties of the feed formulation programs. The program doesn't know that the antibiotic is not a nutrient, but we can set it up as a nutrient and ask it to be included at a certain level that we require, and then the program will do the math for us. So what a nutrient is defined in a least cost formulation program has a lot more flexibility than what a nutrient truly is in nutritional terms. Let's review a little bit of what we have discussed up to now. How many ingredients can be balanced using a computer-based feed formulation program? The answer is as many as the program allows, and a lot of programs allow a lot of different nutrients or anything that we want to call a nutrient to be able to be balanced, which basically means we can add anything called anything we want a nutrient and ask the computer program to do the formulation and to do the math in order to obtain the level that we desire. What is the best least cost formulation program? Well, the answer is the one that fits the needs and complexities of your feed manufacturing operations. Some producers have a single feed mill, have a single farm, and then they can get by with, I'm going to call, a fairly simple feed formulation program. Other producers have multiple feed mills, multiple formulations. Some will have feed formulations they will use for their own pigs. They will have different formulations for the fields that they sell. So it depends on what the complexity of your operation is, how you should select a feed formulation program. Now, do all these cost formulation programs provide the same result? So how do I choose one? Will they all provide the same result? Well, as long as the nutritional matrix of the ingredients, the prices of those ingredients, the nutritional restrictions that we impose in those ingredients, minimum, maximums, and fixed values in that, the results, the formulated result should be very similar from one program to another program to another program. So the question here is basically, if we ask the question, is the math fairly similar across the feed formulation programs? The answer is yes. The math is extremely similar among pretty much all the feed formulation programs that are out there to perform least cost formulation based diets. In summary, a diet has many nutrients to balance using various ingredients. And in the case of the least cost formulation, the term of nutrient can be expanded to more things than the nutrients that we have seen in previous presentations. They could be feed additives and they could be other things we can call a nutrient, pretty much whatever we want, as long as we provide labels for that nutrient in the ingredient matrix values. We can formulate by hand, yes, but it's a very tedious mathematical approach. If we're doing it by hand, then we're more prone to make mistakes, particularly when we're doing lots, if not hundreds and hundreds of calculations by hand. Then the probability that a human will commit an error, it's great. And that's why we have computers. Computers will do all this math for us, and they will do it extremely fast, and they will do it extremely well. But the computer only does the math part, only the math. We have to do the rest. It's up to the nutritionist to input by hand the matrix value for the ingredients, the needs for those nutrients in the formulation, what are the ingredients that we're offering, any constraints, the price of those ingredients, and a lot of other things. All that needs to be done by a properly trained nutritionist. The feed formulation programs cannot check for formulation errors that are not mathematical. Again, you can formulate and a program may give you a result with a formula that will contain 10% salt for a pig formula. And then if you do the math by hand, you see that the numbers are spot on where they need to be. That obviously is not a diet that we can feed. Those types of errors a computer cannot pick up. And least cost formulation takes into account the cost of each of the nutrients that we're asking the program to formulate. And then based on the selection of ingredients that we offer to the program will take those ingredients, will take into account each nutrient value in each ingredient that we're offering, and it will calculate a cost and will perform the calculations, the mathematical calculations, in order to give us the least or the lowest possible cost for that feed.